that f of x equals 1.5x squared. Determine the following probabilities. So the part D is asking for the probability that x is less than -2. -2 is outside of this window that it's defined in. Are you seeing my screen? Are you seeing that?
Oh yes. I'm
Okay.
just paying attention.
Okay.
Yeah.
Okay. So I'm actually going to graph this real quick and snip in the graph and try to make this clear. So 1.5x squared, we're doing that from -1 less than x less than 1. And let me snip that in. So this is a quadratic. Actually, let me grab a little wider interval here. And your instructor could similarly ask a lot of questions that have the same answer. So basically saying, well, what's the area from -infinity to -2? What's the area under the curve on that one? And there is no area because it doesn't even start until -1 here, the +1. So if I asked you the probability that x is greater than 4, that's also 0. Because 4 to infinity, there's nothing under the curve. I could ask you for the probability from, I don't know, -6 to -3, and that's also 0.
Okay. So and then okay, and I'm actually really glad you mentioned that. So I have like I have my notebook here, and like pretty much I highlighted the question that I had. So essentially for this right here, my question was this. So for a PDF, which I believe this is what this is.
This is a PDF. Let's just remind her that means it's defined continuously. Okay.
Yes.
And this is defined continuously.
So
And
so my
go ahead.
so the question was, so for a probability of a number that is not part of the interval, is that automatically a 0?
Yes. As long
Got
as
it.
there's no overlap. Now, I mean, not to be
Overlap.
like let me grab, let's say, because your instructor, well, you don't have chat, and maybe this instructor's answer. The probability that x is greater than -2 would not necessarily be 0, because that's everything to the right of this. So that includes
Oh,
all that. That would equal 1, because it
interesting.
includes that. So, in truth, what you're doing is an integral every time. Although you may not be doing it that way, that is what you're doing. You're finding the
Got
area under
it.
the curve. And you mentioned having some calculus. Maybe, it's been a while since you've taken that, but all these are integrals.
Yeah, and actually, if you like on that snippet, you see how there's like part A, part B, part C, all of those parts. So
Yes.
yeah, so I did integral for all those problems, and actually I did it for this one as well, and the answer actually came out to 0. But then, as you mentioned before, -2 is not part of that interval.
That's
So
right.
then I kind of just thought to myself, wait a minute, if it's not part of the interval, does that automatically mean it's 0? However, right now you just mentioned you just you did a minor change, which instead of less than, you did greater than, which
Yeah,
wouldn't be 0. So it is true, but to a certain degree. It just really depends on the problem as well.
that's right.
Okay, yeah. So I see what you're saying there. You're saying if x is greater than -2, it wouldn't be 0, because if we're looking at it like right there in that graph that you drew, very simple graph, but very, like, I understand exactly what's going on. You have -2 there marked,
Hmm.
and essentially everything to the right of it includes our interval,
That's right.
-1 to 1. So that would just mean, the max probability. Hopefully, I'm not saying this in the wrong way, but the max probability of a PDF is 1. I'm not sure if that's
Well, all probabilities, they all have to sum to 1. And, in this,
yeah.
so so more generally, it's from -infinity to infinity of any PDF that you give me is always 1.
Got it. So then, okay, so just to kind of get this into perspective, imagine that the problem again, no, actually, let me just do a quick change on the interval. Imagine the interval there, instead of it being -1 to x to 1,
Mhm.
imagine that interval was -3 to -5. No, sorry. Let me, sorry. Negative. Yeah, yes. -3 to -5. And we had that same question. Does that mean, hold on, hold on,
Well,
-2?
I got to jump in here because this area, the integral from -3 to -5, 1.5 x squared dx probably does not equal 1.
Oh, it doesn't, even
It
though
probably
negative.
doesn't.
Okay.
Like
Even,
it probably doesn't, like, because your antiderivative is this, you got to evaluate it from -3 to -5. I'm pretty sure it doesn't work, but
so
you
for
know,
example, on that one that you drew right above where you said probability of X is greater than -2 equals
yeah.
1. How did you know that one, like right off the bat, just you knew it was equal to 1? And what I was trying to do just to see if that was true, I'm thinking, well, we had the original question, which is X is less than -2, but our interval was less, was from -3 to -5.
Well, so
But
let me fix this problem here so that it does work. So let's say your f of x is 0.5 from -3 less than x less than -5. So now it works. And the reason it works is that graph from -3 to -5. I guess this gets covered a little bit later in the course. I really don't remember. But let's, from -3 to -5, there's I'm sorry. Yeah, 0.5. So this has a height of 0.5 and it's got a width of 2. So the area is 1 of this rectangle. So now it works. But now because you had a question on this, like, you want to find the probability that x is greater than or less than what in this case?
well, okay, so I guess what I was trying to do, I was just trying to, let me word this carefully. That way it's very clear and concise on what I was trying to do.
Okay.
So let's just say that, so instead of having, oh, actually same thing. So X, oh, but what if we had the same thing? Okay, X,
Sorry, this is mislabeled. It should be -5. It's -3.
actually, what about, yeah, like, well, what I was trying to do, okay, same, okay, that interval's perfect, but with the same question that we had. So imagine it was probability of X is less than -2.
Okay. Yeah. So if you were to ask me if your part A on your exam was, like you just said, probability x less than 2 or -2,
Yeah, -2, yeah.
that equals 1 because -2 is over here and you want
Yeah.
everything left of it.
Okay. Yeah. Okay, perfect. Yeah. So actually, so the only thing you changed there was the f of x, because now it's 0.5 instead of
Yes.
1.5 x squared.
Yes.
Because that if we had our original f of x, which is 1.5 x squared, would the answer still be 1?
No, I mean,
It wouldn't. Oh, got
well,
it.
it's because this thing is this thing only has an area of 1 if between these two
Oh,
limits. Now there are some limits where this happens. Now you do, like I don't remember what chapter it is, but you do actually find C, which is this constant of like, let's say you want it to be cx squared from -3 to -5. Like, you can make this work, but I think your questions are more about like trying to find like these hard and fast rules. And you really shouldn't. You should just integrate this thing every time. You should go to your calculator, FNint or Math 9, whatever. Yeah, FNint, Math 9, and just find the area under the curve every time.
okay. Got it.
I wouldn't make it any more or less sophisticated than that for these types
Okay.
of problems. And truthfully, your probably your exam question is part F, where
Yeah.
you have to find the antiderivative by hand and set the upper or lower bound to a value to get it to work. Um, that is probably your exam question if you get one like this.
Okay. So in this case, the answer to my question would be technically, um, just because, so again, just because the uh, probability that you're looking for of something is not part of the interval, it doesn't mean that it's gonna be zero right, like
Not
right
it,
away.
no, I mean, it could be one. It could be. I mean, could be other things, but most of your PDFs are going to be nice and smooth, like this one up here. So
Yeah.
you could generalize and say, well, probably like If it's outside, it's either 0 or 1. I mean, I wouldn't learn it that way, but that it's reasonable to do it that way.
Yeah, because right there, that one really got me off guard where it's like you said 0 right away, but then as soon as you switched it over from
Yeah.
like X is greater than -2 and it's 1, I was like, oh, and it makes sense to why, but I didn't even think about it that way. I was like, oh wow, okay.
Is there
Um,
another question you can send over for us to look at?
yeah. So then let's see. Yeah, so the other one would be this one. Very it's actually very is it this one actually? Oh yeah. So how would you perform this with the calculator? So
Which one?
uh, the part F. So right, that same image, determine X such that probability of X is less than X equals 0.05.
Yeah. All right. So yeah, this has got a lot in it, and this is, this, like I said, this is probably your exam question. So what it is saying that the integral from -1, because that's your left bound, to some unknown value, which we can actually call X, but you may not want to put X up here, of 1.5 X squared dx, this has to equal 0.05. So let's just go through this, what this is. This is your PDF. This is the lower bound of your PDF. Now, graphically, what we're asking for, because it's X less than X in this notation, it's a little bit weird, but this curve, they're asking for, actually it didn't scale well. There's this curve. I'm not going to draw this to scale, but they're asking for this little area here. They want this area to be 0.05, so the other area is 0.95. So sorry, let me back. This is not correct. So the probably that really it's big X greater than little x. I don't know why they do it this way in this book. Big X little is 0.05. This is the same as this. They're saying the right tail, which is what this is
How do you?
0.05.
I'm assuming because it's positive, that's how you know it's the right tell.
No, it's because
Oh,
it could if they switch the notation to this, they're asking left tail, and it's all in this notation here. So this you got to be very careful attention to this notation, and I would look
um,
at your notes because this is Wiley. This isn't your instructor. I would really look closely at the notation.
what does the little x and the big X represent? Like why does that matter? What does each represent?
So X is literally the place on here on your interval.
Okay, so
And
little x is the actual place in the interval.
yeah, and then this big X is that, let me go back and look and see if they, yeah, this big X is your random variable.
Or random variable, which is what we're looking for.
Well, no, we're looking at that, like the random variable has to be above or below something. Um, you're not gonna like my answers because I don't really like to get caught up in this notation. I would just be very comfortable with what the instructor uses in their notes. Like I would make sure that this actually matches that, because they're going to use this on their exam. Because there's really two answers here. There's the one where you give me the right tail, and there's one where you give me the left tail based on whether you interpret this as left or right.
Yeah, and I guess that would be my question. So looking at that notation, how do I guess I'm really trying to like understand the concept there. Like what does the little x and the big X stand for? So I know how to tell which one it is and like if I should be looking for the right or left tail.
Well, so let's go back to your to your previous questions. I'm going to just snip all of them in so you can see them. You're going to notice that they all use big X. Okay. And then like this 0 here is little x. This is little x. So generally little x is the number. These are all little.
Okay, the number of let me see. So if I'm looking at the other questions,
That's why I said
so
this little x is this, you're picking a number in this interval for that. And big X is just this random variable that's always there.
okay. And then you're saying, but the little x is the actual place in the interval.
Yes. And you see
Okay.
that here, like it says x greater than 0. That's little x. Little x is the 0 because you want everything to the right of 0.
Okay. And then that big X kind of pretty much stands for, well, in this case, big X to me seems like it would never have an actual value since it's
It does not.
continuous.
It does not. That's why it's called your random variable.
Oh, okay, okay. So it doesn't really have a, okay. It doesn't have a specific value, a specific like number value attached to it, like it's
Right,
continuous.
right. Little x is always going to be the one that has the number associated with it. That's probably a reasonable thing to remember.
Okay.
Okay, so we're back to this one here. So what this one is saying is that this right here, okay, there's a number here, and that's why I don't like the way that's written. But it's probably, I would rather write it this way. Probably that big X is greater than some number equals 0.05. Okay, so if you look at your curve, right, from let me go grab it differently, a little better picture here. All right, so I'm just going to set this in. So what we're asking for in this problem is where is 0.05 in the right tail?
Point, let me think of a point in the right tail. So,
So there's some
uh,
there's some number.
okay. So essentially big X is greater than little x. So that means 0.05 is literally all the way at the right side. It's like a little that's a little portion that you kind of like highlighted, right?
Yeah, this area is 0.05. So there are two possible integrals that you could write to do this. The first one is starting at -2 up to I'll just keep using this number symbol because that'll be clear. 1.5 x squared dx. This has to equal 1 minus 0.05, because if 0.05 is in the right tail, then how much is in the left tail?
1 minus that.
Well, minus that. Or you can do the integral from the number. I'm sorry, this is -1, not -2.
Well, wait, when you're using the number sign, is that like X?
Yes, that's x, little x.
Okay.
Because you're going to get caught up on this notation because it's problematic. But yeah, it's little x, little x. So whatever that is, 1.5 x squared equals 0.05. So either one works. You have to be comfortable doing both of these by hand.
Now let me see here. So one of them is 1, it's -1 to X. Okay, -1 to X. And then we have X +1. Okay, now I understand that the ones are coming from the interval. That's our interval. Now 1.5, that's our f of x, and then x squared. Now one of them has a d of x, and the other
Sorry,
one
sorry.
doesn't.
They're supposed to both have
Oh,
dx. Yeah.
oh, okay,
Sorry
okay.
about that.
So they both have, okay. So d of x is now the other one is going to be 1 minus 0.05, and the other one is just 0.05. Okay, how do we? Let me see, 1.0. So if it's -1 to x, so I'm assuming that's on purpose. Why? Again, I guess like the only part right there that I'm not understanding is the first integral, the -1 to x,
Mhm.
that one is equal to 1 minus 0.05, as
Right.
opposed to the other one, it's only 0.05. Why is it that the -1 to x has 1 minus that, but the x to 1 doesn't?
Well, the 1 minus 0.05 is all the other area. I'll do it in blue here. The blue area is everything from -1 all the way up to whatever that value
X,
is.
that x, that x.
Yeah.
Oh, okay, that x. And the other one is from the x,
Yeah.
oh, yeah, yeah, from the x to the x. Oh, I see. Yeah, x is that little value there and all the way to the 1, which is it's a way shorter kind of base there than the other one.
Mhm.
Uh, Okay. So then let me see here.
Do you
Okay, and
do you want us
oh,
to
I'm
work
sorry.
through one or the other? Or is that important to you? Because it has to be done by hand. You can't be, there's no calculator help, at least on a graphing calculator for this.
No, we can use our graphing calculator.
Yeah, but this one doesn't, you can't use a calculator to just spit out the answer. You have to actually find the antiderivative, evaluate the upper and the lower bound.
I
Unless,
think get rid of,
yeah, okay. Well,
yeah.
let me, sorry about that. Let me, yeah, I mean, if you got one and you think you can do that, go ahead. I'm not familiar with what is available in the classroom right now, because I'm not a
Can
student.
we can we compare our answers, see if we get the, wait, I don't know. Oh, I don't know if I did it right though. 1.5.
Yeah, absolutely. So, if you're seeing my screen here, get back. I'll do the one on the left here, I guess. So the antiderivative is 0.5 x cubed, evaluated from -1 to x, and that's has to equal 0.95. So you evaluate the upper bound, 0.5 x cubed minus 0.5 times -1 cubed equals 0.95. So this is 0.5 x cubed, and then this becomes plus 0.5. We do that because of the negatives here. So at this point, I'm going to subtract, I'm going to divide. So I got x cubed equals 0.95 minus 0.5 over 0.5. And then you got to take the cube root of that. So if you have a calculator, you can do that. I got mine handy here. 0.45 over. Yeah, and it's the same number you got before, 0.965.
Yeah, I'm actually still working it out. Let's see here. 1.5. 0.965. Yeah. Okay. Let me see here. So I just worked it out here. Now let me see what I can do. Just getting the trying to get the interval. Can you scroll up to see the if I can see the integral one more time? Let me see here. So I have -1 to x 1.5, and that's x square.
Yes.
Yeah, it is x square. X square d of x, and then okay, 500. Oh, but then it's equal to 1 point. What was on the other? It was 0.95 on the other
Yeah.
side.
Yes, that's right.
Got it. So if I have a number here, essentially, because I got 500 with the integral, I got 500.5. So I'm assuming I'm supposed to like divide that by the 0.95.
Well, that won't get you very close to the correct answer. I mean, what model calculator are you using?
TI 84.
TI-84. Okay. I mean, the only thing that I'm aware of on that calculator is the Math 9, the FN int, and you have to specify a lower and an upper bound when you do it.
Yeah, I did that. I have my lower bound is -1, my upper bound is x, and I
See,
did
but
one.
so you stored something into X at some point, and that's what it's using. Like if you go to your home screen and you hit X enter, it's going to spit out a number like 30 or something. Let me and this will have to be the last thing we do today for now. So let me share my screen and show you this my calculator, which is, it's an older model, but it'll be the same.
Yeah, it'd be kind of nice to know how to reset the x value. That way, there's no values for the x.
Right. So let me share that screen. You share. Okay. So at some point you did like, I'm going to just do 25 store to X. So you didn't do this, but if you go and hit X on your calculator and hit enter, it'll tell you what it is, what the values are. So if I go to Math 9, okay, which is FN int, see, I've got this older one. Let's see, let me just try it. I don't remember the order that I have to substitute in, but let's just go with
It's lower. It's lower and then upper.
Okay, so let's say I do it like you just did there. I go -1, comma x, comma 1.5 x squared. I don't think that'll work. It's missing an argument. Yeah, so let's go comma x and see if that works.
I think you
Yeah.
have to put. I
So
think you
see
have
how,
to put like. Oh,
so see how I get like 912.5 because it's doing
yeah.
it from -1 to 25. Now, if I just redo it and I put in the right value of x, Well, actually, let me clear this out. Let's say I go 1 and I store it into X because I realized the mistake here. And then I do a second entry. Okay, and then I do it. Now it's going to work.
How'd you do that? One store?
Yeah, so you do the number and then you hit STO down here and you store it into X. I guess it was 1.5X squared. Anyway. All right. You just hit store X and then enter. So Alex, unfortunately, we got to stop here. This is kind of the format of lessons. So if you want to schedule more, please visit my website. You can do that. I will say this though, because I think this would be beneficial to you, is it sounds like you're the type of person that loves to talk things out. And if you could get into a study group, you will save yourself time and money. Of course, that means you won't be doing lessons with me, but if you could find people like yourself that are interested in doing the problems together, talking through them, I mean, this is the absolute best way to learn is what you did today.
The way that we're doing them today?
Yeah, but instead of paying me for my time, someone else in the class, like I'm happy to help. I mean, you can schedule as much as you want, but a study group would benefit you because you like to talk things out. That's what people want to hear. If you could find someone in the class that's just a little bit better than you, and maybe someone that's just a little worse than you, you're going to really benefit because you're going to get to both teach and learn at the same time in that environment. But it's totally up to you what you end up doing on that one.
Yeah, I mean, so I still have like a whole week to study and stuff like that. And on Wednesday, I'm meeting up with someone and stuff like that.
Great,
But
great.
I definitely want to use your services. It looks like so far, like from what I can see, like you know how to this stuff. And I
Yes.
just need someone that knows this like really well, like
Yeah.
you, and then that way I can kind of like learn like way better.
Well, that is me. So at the conclusion of our lesson, I'm going to send you a PDF of the notes by email. I upload the screen recording to my YouTube channel, so you'll be able to look back later and see how, hey, what did he say, and if I missed anything. And when you're ready to schedule again, just use my website. If there's a time that you need that isn't available, please text me. I'll try to fit something in for you.
And then you're saying on your website,
Yes.
like that's where I schedule like an appointment.
Mhm.
Okay, let me see. And it's I remember you sent it to me here. I'm in a different, let me see here. Or
Yeah, I'll
actually, I think
just
I see it.
let me just new share it and show you real quick how to do that. So you go to my website, tutoringbymatthew.com, and you click on schedule, meet with Matthew, or just schedule. Either one works. And then you choose virtual lesson because that's what we're doing. That's the top one here. And then you just pick the date and time that works best for you. Obviously, people schedule all the time, so sometimes I don't have any more availability on the day that you want. That's why I said just text me if you're like, hey, I really need a session and I can't wait. I'll see what I
Like
can
right,
do.
like right now, today's Monday. Okay, tomorrow's Tuesday. I'm trying to think.
Alex, I've got to run here. I've got someone waiting for me. I already had to text them to hold on.
Oh, okay, okay.
Yeah.
Oh, okay.
So I really appreciate it, but I got to run. I will send you the information. You can always text or call me if you have any other questions.
And then what's the max that you could do it? Like how many hours?
You can schedule as much as you want, but I mean, you're paying for my time. So be careful
Yeah.
that, you understand that you're committed to it just as I am when you schedule.
Let me see here. Okay, I'm
All
actually
right.
doing it now.
Okay. Thank you, sir. I'll talk to you later.
All right, thank you.
Bye.
Bye.